Well, hello, and welcome to the Train Buddy Shop. It's a bright sunny day out today, and we're going to do a hardware. Try to get a hard one done. Just getting started. We have a really nice engine. I'll show you the picture that we're going for. It's this. This engine is a I don't know if you can read it or not, but it's blue and it says Lukens across here, Lukens steel, and this is a steel mill engine. Some of the characteristics here that we're looking for is it's an NW2 in the 1930s, early 40s, and ran really up until recently. They may even still have it. The one thing that we're going to look for here is it's got a kind of a funky looking light here. I'm not quite sure what all this is, whether or not those are actual lights, but we're not going to do any of that. We are going to do the beacon at the top. That's pretty characteristic of switchers that are being used, specifically in this particular case, because this could be remotely moved in a steel mill where there's lots of heat and whatnot. Oftentimes it's worthwhile to be able to remotely control those locomotives, and so they do, and when they do, they put this beacon on there saying that it's in motion or moving. So here's the loco, and taking the customer info off of there. This is probably, no, it is not probably, it is one of the hardest engines, even though it's a very good quality EMD NW2 by Kato. It's one of the hardest engines to put a decoder in because it is, as you will see, solid metal on the inside. So we're going to have to do some cutting of it, and you see this is hand painted. Another one of the reasons why we want to do this, and you'll notice it even has radio remote on there. Another reason for putting the little beacon on the top. So I'm going to take this out, and we're going to go ahead and get started. I'm going to dismantle it, and we're going to do that off the record here. I'll get right back to it when I get it open, and we can look at what we're going to have to do in order to get a decoder. This particular customer wants an NCE decoder, and so in fact we're going to do that. Okay, so what we see here is first of all, most important here is this is a split frame. That's what makes this so difficult, is the fact that most of the motors and the engines that we see don't have split frames anymore. This is the good news and the bad news. The bad news, again, because it's a split frame, this is just one solid piece of metal. There is no place in here that we have a good room to put. If you were going to try to put sound in this, it would be really difficult. I'd like to do that one time, and maybe I'll do that on another video on one of my engines rather than a customer engine. But in this case, we're just going to do decode. He doesn't want sound in this one anyhow. This is where the light is, and there's already an indentation there. We've got the capability down to, let's see, get a pen here. If you look at the side here, you can see that the motor sits in here. The light here is terrible. I'm sorry, got too much sun in here, but that could be a good thing or a bad thing. If you see this mark and this mark, that's the edges of the cradle of the motor, right? So the motor lies in between that, and then there's the gear, the worm, and you can see the worm right here. And so a lot of this area in here is the worm. Not quite sure how far down we can go here, but let's say that it's somewhere, and we'll know better when we take it apart. But somewhere in here, we have the capability to take that out and put a decoder in that area. So when we take the shell apart, when we take this apart, and we have to do that because we have to isolate the motor from the frame, and this is going to be left and right pickups, and so we also have to figure out how we're going to do that with their mechanism that they have, which is this brass piece fits in like this, and then or something similar to that, and then the wheels then, as you can see, touch the edge of the brass and then transfers it to, so this is hot right rail, this whole frame is hot left rail, and there again creates a problem. Notice that the screw, right, for the coupler goes right up through in between there, so you can't use a metal screw. I did that one time and went, oh, what's wrong? And that creates a short, right? And there are holders here that keep it together, so you have to make sure that you get these little holders off. Otherwise, you take all the screws out and nothing happens because you can't get it apart. But these holders they're a pin and a saddle and pin type arrangement. And just get in there and take those out. But this is a challenge for anybody to take this apart. This it's a press fit with the little dimples here on the inside of this plastic, but it is a very, very close fit, and because it's a close fit, it's almost impossible to the typical hit it like you would for N-scale. And this is typical of an N-scale type locomotive too, where they're split frame, and we're going to do one of those after this video. But this came off fairly easily off of the frame. It's got a pin relationship here also, and I actually got it off before I got the rest of it out. The bottom comes out. It has two little slots that go in two pins, both here and in the back, and this has a specific way of going in, and I'll have to relook on it and see which way it goes. But anyways, what was the other thing I was going to say? Oh, so when you look up inside the cab, it's full. It's absolutely full, and the wires, these two right touch the frame, and they come up to the top up here, and there's a light that's inside of here for the backup light or forward light, depending upon the railroad. And as you can see, this one here, right, just sits in between the two halves of the frame. So these LEDs can be reused here, but we have to do some special arrangement with the wiring in order to make them both functional. And then again, we're going to add one more right there at the top. So let me get it set up in the taking this part apart now. Two screws, right? And again, removing these saddles off the side. And if you haven't already done it, you have to take this off also, and then it will come apart. So I'll do that. There's the second one, and we can just take those screws out. But I'll do that, and then we'll take another look at it. So very much, and that only took a few seconds, but very much like an N-scale locomotive where we have a saddle. We've got this is a plastic case that goes around it. Notice that we said we were going to remove something off the top here, and look how much we cannot remove because I forgot there was a flywheel there. Okay, so now just looking at what we've got left, right, we really don't have as much as I thought we were going to have. We can't really come down here. We can only get from looking at the lumps here. Right, looking at the lumps here, we could only go. That's convenient that one's there. This is the worst case, or the best case, I guess, is to come down here and go this way. Right. Probably don't need to take all of that out. We might be able to just skim it a little bit here. And so that's what my plan is. Let's find out how big the decoder is that we need, and then we'll come back over here and take out from here out, and maybe the decoder's small enough that we can just get a section out of that. Now that's on one side, and I have to do it on the other side too. All right. We have to insulate the motor. We have to take these, make sure they don't touch anymore. We're going to have to solder to those, and be careful how we solder to it. The wires have to come up through, right up through here. They have dimples in it. Now the dimples are there for the stacks, right? And so you see it's got dimples. That's how close tolerances is. These little dimples on the top of this are there to make room for the stack. Okay. And I say this because this is like really, 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 really close. Okay. And then I'll show you how we take this apart to get to the top. But let's now look at the decoder that we're going to use, and go after how much of this we're going to have to remove in order to get into it. Okay then, so according to the NCE website, this is the decoder that we're using, and they have a note and it says fits in the cab. So I guess I could put that in the cab. Looks like there's plenty of room to do that, and so we can do that. I'm going to take another look at how I'm going to do that, but that's where we're going. I wanted to find out whether or not we have the capability to do a top light. It's like 15 different lighting things. There may only be 2 functions. So we'll have to look at that and see what's going on there. Hopefully we had more than just 2 functions, but maybe not. So that's where we are with this. All right. I'm going to open the cab up for you so you can see what's going on. This is kind of an unusual setup. The edges here. Let me see. I need to get my okay. So it's fairly interesting how this thing all is put together, and I've done several of these, so I know how this is done. It's got these little tiny pins that go in the holes. They're really hard to see. The little holes on the side here, right? And I'm staying in the light because I want you to be able to see this. But little holes here, and of course I guess I could get it closer, I guess, and we can look at it that way. But the sunlight is kind of disturbing what I'm trying to show you here. Little holes that are on the side here, and those holes these pins go into, and so you just kind of spread it apart. And then after you do that, then all the windows come out. I don't know if you can see, but the windows themselves obscure the metal and the LED and everything else. So these kind of push in like this, and all of this comes out, and almost in one piece. There's the side pieces, and then there's this front back piece. So I've kind of moved these out of the way. Front back piece, and you can grab hold of that. Here's back piece, front piece with windshield wipers on it. And kind of interesting how they did this. I mean, it's very well put together. It's kind of a puzzle, right? And then finally we get into the LED fixture. And in all respects, I mean, if you think about it, look, we could actually replace and put it up inside of the cab, up inside there. You know what? I might just do that. I might just put that up inside of the cab. Wow, that would be cool. I don't know if they even thought about doing that. I'm going to look on the TCS website and see what they did for TCS. But then I wouldn't have to shave any of this, would I? I'm just pull the wires down. I'm still probably going to have to do something about making physically putting notches in here for the wires. Not that this is so close when it closes up here. Let's take this out. Come on. These are the pins. It's interesting. This is the same. This is the same washer that's used in N-scale. The pins keep it from coming together, and you get about that much. You get about that much, and that's not too bad if you do one at a time. The issue that you have is that here's the flywheels right here, and this is rotating. Okay, so if we put it goes this way, right, and the wires are coming down through here into it, right. But notice that the contacts are way out here on the front or back, depending upon the railroad, but they're way back here, and so the wires have to come through here and go through this, and somehow you got to keep them out of the flywheel. And notice again, there is no room. There is zero clearance across the top here. When the plastic is there, it's right up on that. So you can't like lay it on top and put. You'd have to actually drill or make a groove through here to get it up there. I can't emphasize enough, there is no room for anything in this engine. In any place that you want to put it, you have to make room. Interestingly enough, here on the side, there's a couple of spaces or voids that I used on mine when I put stuff in. I put a resistor in this hole for the LED, and we still may have to do that. There's also a cavity here across the back that we can use, but in order to use those, obviously you're going to have to put holes down through here or put crevices. I put a little man in here. I painted mine all up. We're not going to do that with this one. This is the way it came, but you could do that. The little put meters and everything on there. Okay. So, and if we wanted to be kind of klutzy, we could just take this guy and we kind of like just put him right through there, just like that. So let me look at that, and we'll be right. Alrighty then, we're like back at the next day, and I've looked at a couple things here, trying to decide what to do, and I thought I would open up with you and discuss with you options. I mean, we've got several different ways to handle this. Here's the decoder, and as you can see, I've taken apart the cab and everything else in it. So initially we started off with, if I was going to put it anywhere, it would be somewhere in here. While that may have been how I did it before, I'm always open to other ways to do things. This is a different decoder than what I used. The decoder I used was much bigger than that. It was a typical Digitrax, and this is a TCS one, but Digitrax or whatever, about that size. So this is, with technology improving, this is much smaller. This is, by the way, this decoder says, and this is some more investigation I did well away, this paperwork says this is a N12SR. The 2 there is supposed to mean 2 functions. It's obvious to me when I look at this that there are two other places here, and here. And actually, if you look real close at them, let me see if I can zoom in on that. I want to share that with you. Let's see if it'll focus here. Maybe not. I have to do this maybe. You can see the size of my hand here in comparison with it. Well, now I don't have any light. There we go. There we go. You get rid of that. It says 3 and 4. You see the 2 pads here? I'll point to them, right? Those two metal pads there. So look right above them. Right there's a 3 and a 4 there. See them? So and notice that there's a couple of resistors there in front of it. They say 0 or something, like maybe there's 0 ohm resistors. But whatever, that 3 and 4 are pads. Now what the other marks are out here, the other vias that are there, and whether or not you can use them for other things, I don't know. But this is supposed to be a 2-function, not a 4-function decoder. And when we turn it over, looks like in fact there are the proper devices there for 3 and 4. So so I looked on the documentation online, and it says in fact that oh yeah, there's 2 other functions on the newer ones of these. Now you might buy an N12SR. It is not in the documentation that these exist, by the way. The picture on the decoder on the front doesn't resemble this. If I look at that and compare it with that, they are dissimilar in several different ways. However, I'm going to assume, a bad thing, but we're going to assume that 3 and 4 are functions, because I desperately want to use one of those functions for the beacon on the top, and that would even mean we have another function, so we can talk about what we can do with that. So anyways, let's get back to normal size here, and let's talk some more about where I would put this decoder. The NCE website lists this particular decoder as one for this engine, and it actually says put it in a cab. That's all it says. It doesn't have any diagrams or anything. And if you look at the cab, this is the little guys and everything, you could easily put that in here somewhere like this. So one of the options, there's a void here which is not big enough, but we could cut this piece of plastic out here and we could lay that in there. That would be one way to do that. It did not say, and I thought was interesting, it did not say put it in the cab up in the top, and so we took this little board, not that board, took this board out, right? It has the 2 little metal pieces that go down and pick up from left and right side, and that fits in there like that. This board itself could actually fit up top here. We could take out this plastic here, and we could take out this bulb. It's not. We're probably going to change that bulb anyhow, because it's a kind of a yellow and not really very bright. And we could actually lay this in up top, way up top. It's got thinness profile that we could do it, and it could lay up in the very top of this cab, and you wouldn't see it at all. Matter of fact, if we turn it up like this, and I'm going to try to, sunlight is good in some ways and bad for other things when you're trying to do this, but you can see that there's plenty of room up there for that, and the wires would come out, and we could even do it this way if we absolutely had to. We could put it way up there and you'd never see it. Okay, so those are options. That's 3 different options. So 1, right, 2, 3. The other option, the 4th option, would be to cut the frame and put it in here. There's actually almost enough room to put it right there, right? We cut it back a little bit here and have plenty of room, and even have room to put the other LED here at the end. That would work. This then I looked at another website, Train Control Systems website, TCS, and they actually showed how they would have done this, and their method was to take and cut up here, actually cut out this entire area from here to here like this, right? Cut that all out here, and do the same thing on the other side, right, from here to here, and cut all that out. And you can see where that would be worthwhile, because now you've got a pretty good size space up there, right? And you could put the decoder in there, in that space. This decoder will fit in there. Their decoder will fit in there. Their M1. There's other decoders that would fit in there. Obviously, some of the ones from Digitrax, or even a Soundtrax decoder may fit in that area for sound if you really wanted to. And I might do that on my engine that I have like this, that I haven't touched in years, and have cut this out. But now we have to kind of look at, okay, how much of this are we going to cut out? How much of this, how are we going to run the wires? Okay. So I was talking with a gentleman yesterday about his layout and how we were going to run the wires. And it was like, well, you run the wires like you run the wires. You get the rest of it together. But in this case, there is no room to run wires. So if we were going to do this, let's look at a couple of options, wiring options. So if this was the case, the motor leads, we're looking, this is the front, I guess, of turning this around. This is the front. This is the way that goes. Looking at the motor leads, and taking it apart again. The motor leads are up in this area, right here. So our orange and gray wires, no matter what we do, right, are going to come out right in here. This is, this is going to be orange and red. Not necessarily right there, although we may drill holes if we don't do anything else. But right in this area, we're going to have motor leads coming out. Okay, that's where motor leads are. The front light itself, right, is pinched in like this. Right, so I look at it pinched in like this, maybe even turned over. Doesn't matter. It's an LED, and so it works DC, DCC. Right. It's got leads on both sides. This is the one that maybe we should look at. So in this case, we got this really cool. This is the right half of the frame, right? So this would be the red lead here, right? This would be the black wire over here, right? And now we're going to have a blue and a white. So we get a blue is positive, right? So you have a blue and a white. My machine's not writing here. White and a blue. Okay. And if we look at this, then, so now if we put that right there, look, we got just about every wire going in the right direction. Gray, orange, blue, white, black, right? And the only wire that's not going in that direction is yellow, because yellow and blue. So we have to what is that word? We have to clone blue, right? We have to bring it to the front, but we also have to bring it to the back. So the blue and yellow then goes to the back one, or the other way around, depending upon what we think is the front. According to this, the F right there says that's the front, so that would be the white wire. Yellow would be the back wire. And then if we're going to do anything else, we also have this other spot, if you will, spot to solder a green wire and maybe a purple wire, and then up in the top. So this looks like it's pretty doable. The only downside here is we have to cut the frame. There is one other downside that's not maybe as obvious, and that's where you're going to put the wires. You say, well, you got the wires, they're right there. No, 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 there's no room between here and the top. There is none. Remember, we talked about this earlier, that these little dimples here are there because even the little nubs that come out at the underside of this have to have some place to go. There's no place for wires here, none. So if you want to put them, if you want to put a couple down in the crack, you can do that, but remember, right? Remember how close this is, right? And when we look at, take it apart again, right? And look at where we are. You're talking about putting something here right on top of that motor, and you're talking about running wires down like that, and now they're going to be in the crack. That means that they have to be squished like that. And while that's all doable, look how close we are to the flywheel, right? Look how close we are to the flywheel. That's not really something that we want to do if we can help it. Now, if we had some other piece of plastic in there, if we had a piece of plastic right there that would hold these in there, we might get away with that. We might get away with that. What would be a better plan, though, would be to go ahead and dish out. So I'm going to use the blue here. We were planning on doing some of that anyhow, but from where the decoder is to the front here, right, as long as we're dishing stuff out, we might as well go ahead and create a wireway, right, a wireway here. Just take a little bit out of that all the way to the front here, right, on that side, and then on this side also the same thing, right. So I'm writing all over this guy's engine, but when we get done and we put the top on, no one will ever see it, right? But here we go and cut those out. Now we got fairly good room, right, to run wires. See what I'm talking about? And we can also control the depth here. So if we come down just far enough, just down to there, we can also keep it out of the flywheel. You see that? Okay. So we can keep it out of the flywheel if we do that. Because now the wires will lay in that little niche that we create there. So again, that is one option. And right now it's looking pretty good, other than the fact that I'm going to have to cut the frame. I would much rather cut the plastic. So let's look at our other option. Let's turn this thing around here. And our other option being let's take it from the cab back. So if we look at the cab and how it would sit up on there like that, right? If we had this here, right? These two wires touch the frame here and here, right? Like that when it's mounted. And so this is your red and black here. And again, this is forward. This would be red. That would be red. This would be black. Okay. And then these two wires, now you're gonna have to have a blue in here somewhere. All right, you're gonna have to have a blue, and you're gonna have to have a yellow for the main coming into that. So there's 4 wires in that direction, right? Again, picking up power using the light board. If this guy was sitting up in there, right, all four wires are right there. I would take this board and I'd take the components off the board and possibly solder the red and black wires directly to the board and to these two brass pins that are going to go down and touch, right? But now I'm going to have to run 4 more wires. I've got to run the gray and the orange, which are the wires for the motor, and I'm going to have to run a blue, and I'm going to have to run a white. Okay, so I got 4 more wires have to be run from up top in the cab, right, out to this way. And I'm still going to have to cut some wireways, because now well, more than just cut wireways. Because if you see this dip right here, this cut, and you look at how this thing is made right here, right? It looks like there's plenty of room there for wires and everything, but there isn't. When you come back and look at how it's all put together, this piece goes up in here like this, and it actually blocks off part of that. Again, see where this cut is, right? That cut, and this all sits right there like that. Okay, right there like that. And while it looks like there might be enough, you can't see it there, where it looks like there might be enough room in there, that's all filled in. And it's all filled in with this whole structure in here fills that hole. So when this is up where it's supposed to be, can't really hold it, but when it's up there where it's supposed to be, that actually fills that hole like that. Okay. So we would still end up having to pass wires through this section here, and then, to make matters worse, when you take this and you put it up on top like this, when you put it in there, what you see is this piece, this plastic piece right here, then interferes too. Because when you look at how this sits on top of that, right, that sits on there flush. This piece right there hits the top of this, which means that all of this down in here, right, is interfering. And we'd have to at least cut out enough to allow the wires to pass through there. And then on top of that, when you look at how this is set, right, oh crap, that's what this is right here. Okay, that's all of this area in here. So that means we'd have to cut that out. Well, then we have to cut wireways on the back. It's like, holy cow. All right, so as is usual, there are no good solutions here. There really aren't. We're going to have to cut frames, and again, this is why this is one of the hardest engines to do, because you're always battling the metal that's used in the inside. So that's the bad news and the good news too, because the good news is that makes this one of the best running engines. It has really tight tolerances. It's really well made. It's Kato, top of the line in the business. Real fine Japanese mechanics and engineering here. So while it sounds like I'm poo-pooing this, I'm really excited about doing this and doing it right. And we'll continue on with this in a little bit. But right now I need to have my coffee and try to get my day started. And we'll get back to this shortly.